You are listening to the Horse Radio Network, part of the Equine Network family.
Hello and welcome to this episode of the Disease Du Jour podcast. I'm your host, Carly Sisson, and in this episode I talked to Dr. Sara Langsam about the AAEP's Wearable Biometric Sensor Research Project for Thoroughbred racehorses. As chair of the racing committee, Dr. Langsam has really spearheaded this effort, which the AAEP hopes will help address catastrophic musculoskeletal injuries in these horses. This episode of the Disease Du Jour podcast is brought to you by Bimeda Equine. Dr. Langsam is a partner at South Florida headquartered TFB Equine and manager of its Belmont Park division. Upon receiving her veterinary degree from the University of Pennsylvania in 2002, Dr. Langsam completed an in-hospital internship at Rood & Riddle Equine Hospital in Lexington, Kentucky, before joining TFB Equine in 2003. She became a partner in 2009 and in 2012 expanded the practice to provide year-round services for its clients at Belmont Park in Elmont, New York. In addition, Dr. Langsam serves on the Horsemen's Advisory Group of the Horse Racing Integrity and Safety Authority. Thank you, Dr. Langsam, for joining us today.
Thank you for having me.
Can you get us started by explaining what the Biometric Sensor Program is and how this idea got off the ground?
Sure. In the fall of 2023, following the very public clusters of injuries, specifically for Churchill Downs and Saratoga, AAEP and the racing committee of AAEP decided to put together a forum of invited 25 veterinarians involved in the racing industry in different aspects, private practitioners, regulatory veterinarians, surgeons, imaging specialists. We kind of all got into a room. We initially went through, we zoomed in with regulatory vets from the UK and Hong Kong and talked amongst ourselves in the room about what the actual trends of injuries were, what problems we were all facing, and not to anyone's surprise, this is not a U.S. problem. It's an international issue, obviously, and it's all tied into we keep just trying to get ourselves better. And even though over the last 15 years we've halved our injury rate, our social license to operate is pushing us and us to zero, even though that may be an unattainable goal. That is still our goal. Zero injury rate. So we identified the trends and then we went through all the technology and to see what was available, what was currently out there, whether it's technology. We looked at where we are with biomarkers of injury and how far along that was. And I had specialists or product owners come in and present to us at half-hour increments. Everyone was tired by the end. And then the following day, we just brainstormed and wound up coming up with 9 solid recommendations to the industry to make some alterations to get us better down the path of equine safety. You know, knowing that all the regulations, medication, and safety protocols that have gone into place both before HISA and after HISA are wonderful, but they're probably at their max for what their impact is going to be. And we firmly believe that as we keep lowering this injury rate, the next level will come from technology. And so after laying out 3 different levels of intervention, level 1 being some sort of screening tool, we decided that the most likely path to go down was a wearable biometric sensor that could detect musculoskeletal changes. Looking at the 2 that were commercially available, we just weren't happy enough with just to say you should use this one. We thought there could definitely be room for improvement, both on the use side, but also on the cost effectiveness side, because let's be real, this is, someone's going to have to pay for it. And so therefore we decided, well, we're not happy with what we have. Let's open this up to a wider swath of maybe, groups, companies, whatever, that are not in our racing space. And so that's where we came up with the request for proposal to the broader, and we kind of broadcasted it over a very wide swath of technology companies, and it was beneficial. So that's how we got to where we got.
A long process, it sounds like, but important. Can you just explain briefly what a biometric sensor is and how it's worn, just for anyone who's maybe not familiar?
So each sensor is a little bit different. Obviously, they're not all the same, but they are generally, and let me backtrack a little bit. Biometric sensors can detect anything, cardiac, blood pressure, EKG. You wear a biometric sensor in your, Apple Watch. Your phone has biometric sensors that detect your movement when you look at your health app. So this is just an application of that would be applied to the horse. And so specifically, since we're looking to detect early injury, these sensors are generally either on the girth. There's ones that are based off a tail-based model. Some are worn on the saddle pad. They're all kind of in different places, and they contain gyroscopes, and they can measure speed and stride and all those kind of different data parameters. And some of them also are doing cardiac as well. And then each sensor company has a proprietary algorithm that's their intel. And, they funnel it through to come up with recommendations on how that horse is doing. The whole point of the musculoskeletal is it's really creating a fingerprint for how that horse normally moves. So generally, they will try to alert when that horse starts to deviate from its normal pattern. So it's comparing itself to itself. And obviously, the more you wear it, the more accurate that fingerprint will be. And so the hope was to have them wear it, for this study with every breeze, but some of them could be worn every day.
Today's episode of the Disease Du Jour podcast is brought to you by Bimeda Equine. Bimeda might be the biggest animal health company you've never heard of until now. Bimeda's products have been trusted by veterinarians and owners since the 1960s when their Irish roots began. Bimeda is one of the largest producers of dewormers like Equimax, Bimectin, and Exodus. World-renowned equine athletes also rely on polyglycan, a patented formula that replaces lost or damaged synovial fluid, and Confidence EQ pheromone gel, which reduces and prevents equine stress. Consult your vet and visit bimedaus.com to see where to buy. So I guess going back to putting out a request for industry proposals, what were some of the AAEP's requirements for the proof of principle for the biometric sensors in the study, and how did you ultimately select the companies that are now included?
Okay, so we have put together a subcommittee of our racing committee that is at 8 members right now, all veterinarians, all with different backgrounds and different specialties, but all non-affiliated with there's no conflict of interest. AAEP is not making any money on this. We're altruistically doing this just to increase equine safety. So it was very important that we had a couple people early on that were, and then once the companies had presented themselves, some of them had some conflict of interest. And so they resigned themselves from the committee. So the committee is very non-biased. When we took in the 12 pre-proposals, we each individually graded them and had a standard that is similar to how the Grayson Jockey Club grades their grant proposals. And we just individually read all of them independently and then came together, scored them, and then came together. And these were the 6 that scored the highest. Looking for, obviously, we didn't have any in hand, the sensors themselves in hand, but in the pre-proposals, most of them showed us what their sensor looked like and how they developed them. And we didn't ask for any of their proprietary information. It doesn't really matter for what we're doing. That's their intellectual property. And so we chose the 6 that scored the highest and asked them for a full proposal going forward.
And then how did you select horses for the study? And I know that the actual research part of the study has just kicked off this past month. So, how many horses are included and how did you choose them? And what is the overall study population?
So the sensor companies are actually in charge of recruiting. They have to each one was tasked to find 100 2-year-olds of 2020, thoroughbred 2-year-olds of 2025 that would be in training and racing in the United States, no international participation. Just there's already going to be enough variables because they're all going to be in different locations that we didn't want to add an even bigger variable of being out of the country. So these are all voluntary. They went out and recruited from various ownerships, various farms, because obviously these 2-year-olds are not at the track yet. They're all at training centers currently in different broken and starting their early training. So we don't have any hard data yet, even though it started January 1st. A lot of them are just wearing them and trying to get out the kinks of making sure they're properly, making sure they're getting data so that when reliable breezes and more consistent training that we will not lose any data points because of human error. So yes, so the companies each recruited 100. Some have actually recruited 140, 150 horses, which is great. Some of them are using not the same horse, but are on the same farm. So there's a couple of farms that are helping out and using 3 different sensors, which I think is great information as well for the more subjective part of the study, which one was easier to put on, which one, because in the end, you want these to be as easy as possible, take up the least amount of time so that the compliance is strong. So that's all kind of subjective data we may be able to get at the end of this. And so, yeah, it was on the sensor companies to find the horses, but they've done a great job. And I'm very encouraged. We have a minimum, I think we'll have about 700 2-year-olds as we go forward. I'm still waiting on the last final lists of microchip numbers. So,
yeah, that's a really impressive number.
Yeah.
So what sorts of data are you collecting on each horse, both subjective and objective, and how is this going to help you determine the accuracy of the sensors?
Okay, so what we're basically doing is each week that they breeze, generally thoroughbreds breeze once a week, usually, anywhere from 5 to 7 days, maybe 8 if there's weather, it's certainly up to that. But every week they are required to send us a data point for that horse outlining the characteristics of the breeze, distance, time, what kind of track maybe, and like how the surface is it, was it wet? Was it fast? All those kind of things. And then based off of that breeze, the sensor company will take that data and then churn out a green, yellow, or red rating for that breeze. Meaning green, everything seems fine. The horse is moving as it always has. Yellow, it's starting to change. Red, there potentially could be a problem. And so, we'll keep logging that data. If a horse misses 2 breezes, then there will be a required veterinary exam by the farm or trainer's attending veterinarian. And from that, we just need to know, why did that horse miss 2 breezes? Was there a musculoskeletal injury, or was it colic or a respiratory problem or some sort of immaturity? And then that kind of will get collated. So we're looking to see if the horse comes up with a problem but kept having green lights. So did the sensor miss it, or vice versa? Is the horse, throwing out these red ratings based off the sensor, but the horse continues on in training, is sound, veterinary exam comes up with nothing, in which case it would be a false positive. So in the end, we'll look to see who has the most false negatives, who has the most false positives, and how that data trend collated. And it's really just that simple. A lot of these sensors are going to churn out a lot more data than that, and we're not really asking for that. It will be part of, some of them have apps, some of them, have all this fancy graphs that they're going to be able to show them. But in the end, we really just want to know, was the sensor able to pick up an injury, or was it overreading something and there was no injury? And we chose 2-year-olds specifically because we know that, 40% of them are going to come up with some minor injury, whether it's buck shins or tendonitis. And we really need the sensors to be that sensitive to be able to pick them up. So.
Right. And are you going to follow all these horses just for 1 year, or are you going to continue until they're racing on the track?
Well, hopefully they should be racing on the track towards the middle of the end of the year. They're starting to be allowed in the middle of March, usually for most North American tracks. But no, the study will run until December 31st, 2025. And if a horse needs time off and then comes back in, we will allow them to come back in the study. They just can't add any more horses throughout the year. Okay. But that horse can take a break, and then if it's able to be back in training before the end of the study, then we'll allow them to come back in.
Great. So what are some of the long-term impacts you hope this research will have on the horse racing industry, and maybe in the horse industry in general and different disciplines in the future?
Yeah, so, we're just trying to figure out, these sensors are certainly I wouldn't say they're infancy, but they're still being tested out. There's been minimal usage in racing, Churchill Downs has been using one sensor company, but just in races. So, one data point a month. And there's definitely been some more on the cardiac fitness side that have been used in training. But we're hoping that these sensors are like our hope, if it works, would be that they're like the true screening tool that a horse can regularly use. And then all they would serve to do is tell you that there's something up with this horse. And then the veterinarian would come in at the next level and just look at the horse more in depth, what's going on. If there's nothing on the soundness, maybe that goes to a scintigraphy. That's all they're supposed to do. They're not going to tell you if the horse is lame specifically in one leg or another. It certainly will not replace a veterinary exam, but it will just alert the team around that horse that, hey, you should probably take a closer look at this horse. There could be a problem. And so the hope is to catch early injury, catch injury even earlier so that we can have an earlier intervention point, and prevent, obviously, yes, the catastrophic breakdown, but also on the economic side, if we catch injury really early, we could prevent surgery, we could decrease rehabilitation time. And so we'd make that horse able to come back into the active racing population even longer. So on an economic side, we may be able to keep horses longer in healthy race training and racing by being able to detect injury that much sooner. So, and I think this will be, obviously different disciplines do different exercises, and these sensors are being trialed out in eventing and that kind of stuff. So I think it could span not just racing. And conversely, if the study, none of them are reliable, then obviously they're not ready for any kind of implementation by the regulatory authority. So, which could be, if we do find multiple ones that are ready, then that would be the next step. But we would just basically hand it to them, and that's up to them to figure out how that would go on a timeline.
Right. And can you talk about what happens when the regulatory authority gets involved? Is your goal with the study to make your formal recommendation for which sensor to use, and then would it be up for owners and trainers to adopt that voluntarily, or is there going to be some sort of larger industry-wide push?
I would see that there probably could be some sort of mandate to use one or others. I would love for all 6 to be reliable enough to say, hey, you can use any one of these approved sensors. And I don't think this ever stops even after implementation, because I would hope that, especially if we have multiple ones that are reliable enough to use, that will stimulate technology to keep advancing. Like your iPhone the iPhone 4 is nowhere near the iPhone 16. And so This technology almost has to keep evolving. And, that usually comes from consumer pressure to keep being better. So in an ideal world, I could see where HISA, which is our U.S. thoroughbred racing regulatory body, would have like a panel that would approve certain sensors to be used, where this would just be a launching off point for that to be a bigger long-term plan for implementation. So yes, it would be mandated, but you would have the choice of what sensor you would want to use on your horses. And there's going to be a couple of hard conversations that the industry is going to have to have about data ownership and who's going to pay for these sensors. And there's no way to avoid those conversations. But this initial work is, since we don't have any financial interest in this directly, AAEP is kind of like the perfect non-biased group to get this started and see if these are ready for any kind of implementation. And if they are, then we'll make our recommendations of this 6, which one we think are ready. And then, they'll just take the ball and run with it.
Right. Well, this is really exciting, and I'm looking forward to following the project as the year progresses. So thank you so much for coming on and sharing. Do you have anything more you'd like to add before we wrap up today?
No, I'm excited to share, and I'm excited to really see what we're going to get. I think it's going to be really good. So
yeah, well, maybe we'll do a follow-up this time next year, and you can let us know how it all worked out.
Yeah. Very good. I would be happy to do that.
Well, thank you again, Dr. Langsam, for joining us. And thank you so much to our audience for listening to Disease Du Jour. If you have any questions or suggestions, please send me an email at csisson@equinenetwork.com.